Welcome to our first flip video for our second unit, sort of our first official unit of content. This is going to be our unit about population. So please go ahead and label this one as flip video 2.1, indicating our new unit. How is population measured and analyzed? We're going to break down 3 different ways to measure population density and distribution. So we're going to, the difference between density, high and low, lots of the frequency of the people versus where they are spaced out in relation to one another are 2 different ways that geographers measure this, and then in turn use that information to figure out the effects that population density, how much, and distribution, where they are, can affect the physical environment that people live in. So here's where we see those 2 concepts of density and distribution actually being applied to real content here of population. There are 3 different ways: arithmetic density, physiological density, and agricultural density. First things first, please write arithmetic on the left and population on the right, because arithmetic density is the same thing as saying population density, where you're simply figuring out how many people live in a given space. Now these concepts are tricky. What we're going to break this down is I'm going to teach you first the formula for each one of these types of measurements. Then we're going to talk about what it tells you, what it doesn't tell you, and what geographers use it for. So very much the first and most basic one is the same concept of what you'd consider before you walked in the door of this class. Population density, total population divided by the total land area. So how many people are living and how big is the space? So for example, in the United States, and these are estimates, and I think I actually crafted these 2 years ago, so they could be a little out of date. Let's say just estimating that we have 300 million people in the United States, approximately 3.7 million square miles. Our population density would be 80 persons per square mile, or 80 people per square mile. That's pretty straightforward, pretty easy enough. Now here's what that density shows us. Please put that on the left-hand side, that question there. Population / arithmetic density. If it's high, there's a lot of people living in that space relative to the size of the country. So for example, there may be a lot of people living in that given space for how big it is, or few people living in that space given how small it is. If population density is low, there are not a lot of people living in that space relative to the size of the country. Let's say it's a huge country, then you'd have a very large denominator with not a lot of people living in it. Not a lot of people for the size of the country, or a lot of people, high numerator, for this small denominator. That would be high population density. What it doesn't show us, that doesn't tell us the distribution of the people. We know high or low, a lot of people, few people, but it doesn't tell us how close or how far away they are from one another. All those people could be living in one space, or all of them people could be totally evenly distributed across the country. Population density, this calculation here alone, does not tell us enough information. For example, let's look at the United States. Here's a cool map that shows us the graduated symbol map here. We see that the area of the United States with the vast majority of the population is concentrated is called the Bosch-Wash corridor, the corridor between Boston and Washington, D.C. on the eastern seaboard. You also see that we have a large population concentration in Southern California. There's the various cities across the United States. You see Chicago. But if we were just doing a population, if we just calculated a population density, it wouldn't tell any of us any of that. It would just simply say 80 people per square mile. So population or arithmetic density tells us density, it does not tell us distribution. So that doesn't help us understand, well, are those 80 people per square mile, are they putting a very big impact on the environment, or are they not impacting the environment very much at all? So what we need is a second, here's another example of the distribution of the population of the United States with lights at night. You can see the clear distribution. So again, we don't know. Are people, just from a number 80 people per square mile does not tell us the pressures that the people are putting on the land. We have a second formula to help us with that. That's called physiological density. We calculate physiological density. You can put formula on the left-hand side, physiological density formula on the left. Total number of people divided by the total arable land. Arable is the term that's used to describe land that is suitable for agriculture. We should say agriculture, not agricultural. For example, in the United States, our agricultural density would be 453 persons per square mile. Here's the reason why we use this. This gives us a better indication of the distribution of people on the farmable land. So for example, if the physiological density is high, that means that there are a lot of people, lots of people living on arable land. Go back to the formula. Think of the total population being very high, right here, and total arable land being very low, right? Or alternatively, total population, and if that's the case, then that means there are a lot of people living on that farmable land. And that means that they're putting a lot of pressure on that land. They're putting a lot of pressure on that land to be able to produce crops to feed them. High physiological density gives us a much better indication of the concentration of people. Are they all clustered on that arable land? Then the physiological density is high. And I want you to consider almost like all the people standing on top of the tabletops in this classroom. If the classroom itself is our country and the arable land is the the tables are the arable land. Imagine all the people climbing on top of that arable land and putting lots and lots of pressure on the land to perform agriculturally. If physiological density is low, then there are not a lot of people living on that arable land. It gives us more indication of the distribution of people. People are more widely dispersed across the country, so there's less pressure on that land to produce crops. So what it doesn't show us, so that's the physiological density. Arithmetic and population tells us density, how many people, how few people, doesn't tell us the concentration. Physiological density gives us a better understanding of the distribution of people, better idea of who's clustered on the arable land, and more importantly, how much pressure are those people putting on that land in order to feed themselves. What it doesn't tell us is how efficient those farmers are. So we know a lot of people are living on that land, but what if only 5 of those people are farmers, right? If there's thousands and thousands of people living on the land, then we know there's lots of clustered population on the land. Doesn't tell us the actual effect of that. So for example here, let's go back for 1 minute. Physiological density. In Egypt, if we only had a number of their population density, we'd only know whether there's a lot or a few people living in the entire country. What we wouldn't know is where they live within the country. Take a look at this map here of population distribution in Egypt. Physiological density would show us that the vast, vast, vast majority of people in Egypt live directly along the Nile River. And throw back to your elementary school history class, you know that's because that area is farmable, it's arable. People can actually live as opposed to the rest of Egypt, which is largely a desert. So physiological density is what came into play here. Physiological density is very, very high in Egypt. That indicates to us, just as the map shows, that there are lots and lots of people living on that arable land. The population is concentrated along farmable land, and they're putting pressure on the land as a result. You can see here across the world of physiological density. If we looked at population density in China, might be it wouldn't be super high necessarily because there's so much land. But their physiological density is very, very high, which means people are clustered along the arable land, right? That gives a very clear indication of the distribution of people. Here's the agricultural density. Okay? So lastly, what we need to know, as I mentioned before, well, how many of those people are actually farmers, right? What if there's 1,000 people on the arable land, but only one of them's trying to farm? What we need to figure out to truly understand how much pressure land is being subjected to, how much pressure people are putting onto farmable land, we have to look at the last formula, what's called agricultural density. That's the total number of farmers who are living on that arable land. For example, in the United States, we have 1.6 farmers per kilometer of arable land. Why do we need this? Okay, 2 countries could have the exact same physiological density, lots and lots of people living on that arable land. But those 2 countries might produce vastly different amounts of food. So let's start from the beginning. We figured our population density, how many people are living in the place relative to the size of the country. Second, we figure out where they're concentrated. Are they clustered? Are they dispersed? Third, we're going to figure out, in order to understand the pressures of the land, we're going to figure out how many of those people are farmers, because that will then show us how much true pressure and how much interaction those people are having with the environment that they live in. If agricultural density is high, meaning lots of farmers living on that arable land, think of the tables again in the classroom, then that means that it's probably going to be a less developed country. Because if all of the people living on the farmable land are all farmers, then that's likely an indication that they don't have technology available there that would allow only one person to do the job of many. In other words, this is likely a lesser developed country if you have a very high agricultural density, because all of the people living on that arable land, think back to Egypt here, If all of those people are farmers, that's an indication that they're only producing enough food to feed themselves, right? Alternatively, if agricultural density is low, then there are few farmers living on that land. That's usually an indication that this country is a more developed country because the farmers are efficient. Consider those thousands of people. If only one of those people is a farmer, then that's pretty good indication that he's a very good farmer and he's able to produce a lot more to feed the people. Typically, not always, typically, high agricultural density is putting tremendous pressure on the land to support the population that lives there. Alternatively, if the agricultural density is low, the land is being used effectively and efficiently to produce many more people, to feed many more people, which is usually an indication of a more developed country and an indication that the population is more greatly dispersed across the country. So here's what these three things bring us all together with. We studied these because we want to look at calculate where people live, and more the pressures at where they're distributed, the density of a population, the distribution of the population, and then bringing it all together, the pressure that population distribution and density puts on the land itself. There are your analysis questions. Please go ahead and complete those, and I'll see you in class.